SpaceX has become synonymous with pushing the boundaries of space exploration. From its humble beginnings, the company has relentlessly pursued the goal of making humanity multiplanetary. Each launch, each mission, is a step closer to that grand vision. But the path to progress is rarely smooth. This is the story of SpaceX Flight 6, a mission that exemplified both the triumphs and tribulations of pushing the envelope in spaceflight. Flight 6, part of SpaceX's Falcon 9 program, was a pivotal mission. It marked a critical step in the development of reusable rockets, a technology that promised to revolutionize access to space. The ability to launch, land, and relaunch rockets would drastically reduce the cost of space travel. However, achieving this ambitious goal required overcoming significant technical hurdles. SpaceX's journey to Flight 6 was marked by a series of impressive achievements. The Falcon 9 rocket soared through the atmosphere, carrying its payload towards orbit. Flight 6, while ultimately a successful mission, revealed some unexpected issues. These issues, primarily centered around thermal stress and material limitations, provided invaluable insights for SpaceX. These were not failures but rather opportunities to learn and improve. One of the most significant challenges observed during Flight 6 was the unexpected level of thermal stress experienced by the rocket during re-entry. The intense heat generated by atmospheric friction pushed the limits of the rocket's thermal protection system. This highlighted the critical need for robust heat shield technology, capable of withstanding the extreme temperatures encountered during hypersonic flight. Another key issue was the performance of certain materials used in the rocket's construction. The extreme conditions of spaceflight put immense pressure on materials. Despite these challenges, Flight 6 achieved its primary objective, delivering its payload into orbit. The data gathered during the mission provided crucial insights that would shape the future of SpaceX's reusable rocket program. Re-entry is a fiery and turbulent affair. A spacecraft returning from the vacuum of space slams into the Earth's atmosphere at hypersonic speeds. This generates intense heat, enough to melt even the most robust materials. During Flight 6, the Falcon 9 rocket experienced higher than expected levels of thermal stress during re-entry. The heat generated during this phase pushed the limits of the thermal protection system, leading to some degradation of materials. This thermal stress highlighted the critical importance of advanced heat shield technology for reusable spacecraft. Unlike single-use rockets, reusable rockets need to withstand multiple re-entry cycles. The data gathered during Flight 6 allowed SpaceX engineers to analyze the performance of these systems and identify areas for improvement. Understanding the factors that contributed to the challenges observed during Flight 6 is crucial for developing effective solutions. SpaceX, with its data-driven approach to engineering, conducted a thorough analysis of the mission to identify areas for improvement. One key factor was the aerodynamic design of the rocket. The shape of a spacecraft plays a crucial role in how it interacts with the atmosphere during re-entry. Even slight variations in shape or surface features can significantly impact airflow and heat distribution. SpaceX's analysis of Flight 6 focused on optimizing the rocket's aerodynamic profile to minimize drag and reduce thermal stress during re-entry. Another significant factor was the choice of materials used in the rocket's construction. SpaceX utilizes a range of advanced materials, each chosen for its specific properties, such as strength, weight, and heat resistance. Flight 6 highlighted the need for even more robust materials, capable of withstanding the extreme temperatures and mechanical stresses of multiple re-entry cycles. This data would prove invaluable in developing more advanced thermal protection systems for future missions. SpaceX, true to its innovative spirit, viewed the challenges of Flight 6 not as setbacks, but as opportunities. The company's engineers embarked on a series of improvements driven by data and a commitment to pushing the boundaries of spaceflight. These improvements focused on three key areas: heat shield development, cooling systems, and landing strategies. One of the primary areas of focus was the development of more advanced heat shield technology. SpaceX engineers explored new materials and designs, aiming to create heat shields that were both more robust and reusable. In addition to heat shield technology, SpaceX also focused on enhancing the rocket's cooling systems. These systems play a critical role in regulating temperature during re-entry, preventing critical components from overheating. Finally, SpaceX refined its landing strategies to minimize the stress on the rocket during re-entry. By fine-tuning these parameters, SpaceX aimed to decrease the thermal loads on the rocket, extending its lifespan and enabling more reuse cycles. SpaceX's journey extends far beyond Flight 6. The company has continued to make significant strides in space exploration, achieving numerous milestones and pushing the boundaries of what's possible. One of SpaceX's most notable achievements is the continued success of its Falcon 9 program. The Falcon 9 rocket has become a workhorse for SpaceX, reliably delivering payloads into orbit for a variety of customers, including NASA, commercial companies, and international space agencies. The rocket's reusability has significantly reduced the cost of access to space, making it possible for more organizations and researchers to participate in space exploration. Beyond the Falcon 9, SpaceX has also made remarkable progress with its Starship program. Starship is a fully reusable spacecraft and super-heavy lift launch vehicle designed for interplanetary travel. With its immense payload capacity and ambitious goals, Starship represents a significant leap forward in spaceflight technology. SpaceX's achievements extend beyond its own programs, supporting government missions, including those for the United States Space Force. SpaceX's journey is far from over. The company, with its unwavering ambition and relentless pursuit of innovation, continues to push the boundaries of space exploration. From reusable rockets to interplanetary spacecraft, SpaceX is shaping the future of spaceflight and inspiring a new generation of explorers, dreamers, and innovators. SpaceX's legacy will be one of democratizing access to space. By developing reusable rockets and reducing the cost of spaceflight, SpaceX has made it possible for more organizations and individuals to participate in space exploration. Beyond its technological achievements, SpaceX's greatest contribution may be its ability to inspire. The company's ambitious goals, bold vision, and unwavering determination have captured the imaginations of people around the world. As SpaceX continues to reach for the stars, the challenges it faces will undoubtedly lead to even greater innovations. The lessons learned from Flight 6 and every mission since will serve as stepping stones on this incredible journey, propelling SpaceX and humanity towards a future written in the stars.